Figure P2-23 gives us an opportunity to introduce the whole wizard. Geometry is not terribly complicated. We can use the Oberon slot function to put in our geometry, and it's actually called out with which one? Let's see. No, it has the dimensions on it. So sometimes the whole table will pick that up. This might also be a good one to optionally bring in the drawing and show how that table is generated. We don't typically put the table in or try to put the table into the part. We usually reserve that for the drawing. So let's get started. This is going to be an inch. We'll go to the front plane, open the sketch. I think I will put the fillets as a fillet feature, so fillets and chamfers go in last. Looking at this one more time, our datum for the table is off of this corner, so just to make it a little easier, we will maintain that. So I will go into a corner rectangle, and I'm going to because of the way the features fall out, I'm not going to worry too much about sketching in a lot of geometry to start here. So 6.39. We have a 3.90. And we'll start putting in the notches. And we could use the jog, but by the time I find jog, most of the time I am, and there was my midpoint. I do want to be careful of that, but by the time I find the jog, I can draw 3 lines and get done with that. So in this case, I don't want the midpoint. I did see it pop up. That little yellow box told me that I had already clicked on it. All right, so going over to the property manager or clicking on it, we have coincident. So I do want it to be coincident, but if when that said midpoint, I can make that go away by putting in or deleting the the little box, or deleting it out of the property manager. All right, so 3.35. And then we'll go 1.82. Let's see, we have now one of these is going to be to the virtual sharp. So I'm going to assume that that extension, oh no, that is going to the center. So the 1.61. And then our steps, 0.55 and 0.75. And that is a chain dimension, so I'm going to say 200 thousandths isn't very much. And then the depth, appears we are missing a depth. So if that's 0.75, rough scale, going to go with an inch. Again, if there's a missing dimension, you can't find it. Don't spend a lot of time messing with it. We have the tools. I'm going to set it to be an inspection, and then I'll mark it for the drawing. So let's go back into select. And it's down a little ways. Mark for drawing is just off of the screen that I'm using. So it highlights it, it notes it. If I insert, I don't insert dimensions very often, but if I set myself kind of a reminder, that would be a dimension that comes in and needs to be resolved. So let's see, we have 238.29. That's an interesting dimension. So we'll come off of the flat. I want to get into into that mode. The 238 is pretty darn close. We'll go with the 29. It rounds for me. Double check my number, and that should be good. We can use the contour and region. So kind of group those. Let's see, what was the thickness? 1/2 inch. So 0.5. Contour and region is the interior. This time I want it to go away from me. So I can reverse that direction. And again, getting back into it if I change my mind. It's not permanent. We just toggle, is it going in the Z away from us, negative possibly direction, or towards us in a positive direction. All right, so going through the A1, A2, A3, these were not grouped up in the table, so A1 through A5 are all 1/4 inch. So I'm going to use the hole wizard. Again, I like to pre-select, so I'm clicking and we're going to look at this function for inserting customized holes. So advantages of the hole wizard over drawing these in. If it's a threaded hole, we don't have to calculate the major minor diameters. If I change my mind for this being a 1/4 inch through hole and decide to make it a threaded hole, it's a lot easier to change. Counterbore holes, countersink. When I click on this, we're going to see all of the available geometry. So standard counterbore is going to allow a bolt or screw to be sitting subflush. Definition of a bolt. When you think of bolt, you think of nut and bolt. So basically a bolt is going to be a compression style going through one or, well, one component really doesn't do that much, but okay. Let's just say 2 or more components with usually a washer so that the washer is the sacrificial piece that if it's going to gall, that the bolt head, that the nut has something to turn against rather than your probably more expensive part. Countersink is going to sit subflush, but it's also going to have a certain amount of locate. Thing to remember with countersinks, in inch we have 82 degrees. In metric we will have an included angle of 90 degrees. They somewhat interchange, but there's a little bit of rock or float in the countersinks. For this assignment, we're going to be doing the through holes, since all of these are given as diameters, but then as an example, we'll go back and we'll probably change the 1/4 inch to 1/4 20s. All right, so that's just a matter of there is our straight tap, a tapered or a pipe tap. A pipe tap gets tighter, seals more for fluid retention. So whether it's air or water, any type of flow, that the taper kind of self-seats as you're driving it in. So if you think of any plumbing fittings with those pipe fittings, that's our tapered. Going into the legacy, prior to what, 2004, 2000, somewhere in there. It's been a while. The legacy hole was a go through and set your definitions, and you kind of had to know there wasn't really a library, but it was definitely a lot faster than cutting, extruding, cutting the counterbore, doing all of those geometries. And then probably in the last, I want to say, oh boy, 2014, 2015 was when the counterbore slot, countersunk slots, they don't get used a lot, but they are handy. And the slot comes in. So we'll look at both the ob round and the slot tool for our piece here. So we want a standard hole. It is going to be an ANSI inch. I know that this is a fractional drill size, and what does it say about the metric and the standard fractional decimal letters? If you use them enough, you will remember them. Other than that, there are our drill charts that tell us what all of these numbers kind of translate to. So we know that we're going to a 250. I can show decimal values if I don't recognize it. So we'll scroll down, pick up our 1/4 inch. It is going to be a through all. Don't typically put near side countersinks. If it's just an edge break, just deburring the hole, I would rather see a note on the drawing that says edge break to 10 thousandths or 20 thousandths max, or some number that would make sense. All right, so looking at the table then, let's go over to the picture because it's a little bit bigger. We have the X location, Y location, the size, and the tag is A1 through A5. So I'm going to place them roughly, and let's just jump back into here so I can get my positions, A1, A2, A3. And I'm not sure about switching between these A4 and A5. So that was kind of what I was afraid of if I click in the work area. So right click to select to get out of the point. So why are they putting in points? The Hole Wizard generates 2 sketches. One sketch is the point locations for each of these holes, and the other sketch is a revolve. Now we haven't done revolves yet, or much. We're going to do plenty of revolves, but basically a revolve creates a cylinder, and it's an easy way to generate this geometry. So we'll take a look at that after we finish. So right-clicking and going into Smart Dimension, or coming up to the Command Manager in Smart Dimension, first hole location 0.25, and then the Y location 0.25. Now I could do this as an ordinate. With 5, I don't know that it's going to be, any great great advantage to having those ordinates. A2 is 0.25 and 3.1, so I do want to take advantage of the vertical and just say if the bottom one moves, then the top one's probably going to move too. So select the point, hold down the control button, select the other point, and we make those vertical. All right, so our A3 then, 0.88 and 264. Oops, missed. 0.88 and 2.64. Right, going to the next one, 4.88 in X and 3.65. So we're pulling all of these off of the same datum, meaning that the edge that we start with, we're going to continue pulling those dimensions off of those lines, 0.614. And then we have another situation where I can right click, go back into the select, which is the same as hitting the escape, and control select. All right, so whichever way we go, select, control select. And if this is already highlighted, already has the point there, then I don't need to reselect it. I'm basically deselecting it at that point. When I set that to horizontal, they'll jump into position. Let's see, 4, 5, A3 is not in there. Why didn't A3? Oh, A3 jumped off of the material. So 2 point, that would help. So got an extra number in there, 2.64. I was doing my quick check, and well, there's nothing there for it to cut into, so there's no not going to be a hole there. All right, so the B and B1, B2, let's identify those. B1 and B2 are kind of off of the corner there. So let's go back in. I will pre-select. Well, let's do if I don't pre-select. All right, I like the pre-select, so we go into the hole wizard. Let's see that size. I lost my chart. There we go. The B1, B2 are 0.4, so we're going to have to look at all drill sizes. We'll do the pull down and we're going to find the one closest to 0.4. So way back when we study ancient history, like the 1800s or so, when went through and did kind of an analysis of the standard rather than having a drill size every 10 thousandths or every 5 thousandths. There were basic clearances, and it was kind of a statistical analysis that said, hey, these are going to be letter drills, these are going to be machine drills, and we get close, but in the case of a 0.4 with a standard 2 decimal place tolerance, depending on the industry, would say plus or minus 10, sometimes up to plus or minus 30. All right, so if I'm within that 4 thousandths, 3 thousandths tolerance, so what I'm looking at is the 0.4004, that 004 larger, do I want the hole to be a little bit bigger or a little bit smaller? So for clearances, we typically want it a little bit bigger. If it was something that was going to be locating, be a little bit smaller, and then if it had to be exactly 400, we'd be making another decision. So go into positions. Anytime you see 3D sketch, do not pick on the 3D sketch. We're going to come out into the work area, pick the face, and place 2 holes. Let's see if I can move that back a little bit. Get into the larger chart. All right, so 0.68 and 0.129. All right, same datum, 1.29. And then the other one, 1.28 and 0.56. Okay, just a quick double check. And we go ahead and accept. So pre-selecting again, we'll go into the hole wizard. The C is 0.29. You get down to these singles, it's probably not going to be any great advantage over drawing them. But again, if these change or we need to add more, then we can come back to the value. So just need 0.29. Now we'll see what we got close. Now, there is actually an L drill, 0.29. And the position for C is going to be up there a little ways. Okay, and then we'll go into the smart dimension. Move that one over a little bit. And we have 1.76 and 2.92. Okay, double check that. And we can go ahead and accept it. D then is not too much further out, and D is going to be 0.33, which will probably translate will be around 1130 seconds. So we'll just stay in the all drill sizes. So 1130 seconds, a little bit larger. Oh, didn't want to do that. Get back to my chart here. 0.33. So 332 is probably going to be the closer. And we were in D1. Oop, jumped out of that. A little too quick. All right, double checking. All right, so here's the sketch. And if we look at a straight hole like that, then it's going to revolve the rectangle. So that is the sketch that we really don't want to mess with. Sketch 8 is the point location or locations. And just like any other feature, we can go back in. All right, so the 3.32 was okay. Got myself confused on the numbers. 2.66 and 3.16. All right, E is going to be a 0.42. So pick the face, and we can pull that out. Oh, I went into the sketch, so let's exit out of that. Discard changes, pre-select the face, whole wizard. Either that or I hit cut extrude instead. And we're going to scroll down. So probably the 2764 42188. Have a position that's down here somewhere. Right click, Smart Dimension, or to the command manager in Smart Dimension. And the D value. Oh no, E value, 3.38. Fun part of charts, managing all of those dimensions. And 1.13. All right, and then our F, let's see, where is F? F1 in the upper kind of middle, and F is 0.32. Well, I think I would be looking at finding out what the two holes do that are 10 thousandths off, and put them in the same tolerance zone on that one. But 323. Staying with want to be a little bit bigger. Right click, Smart Dimension, and we're going 3.71 and 3.43. And accept. And then last, the G1 is 0.73. Pick the face, go into the hole wizard. I'm going to scroll down a little ways. So yeah, probably the 0.73. Get into the positions. We'll go into the Smart Dimension, 4.39. And 0.71. All right, so first, probably the one that makes most sense, well, since I've gotten this far into it, let's go ahead and save this, because I really don't want to start over at this point. What are we at? 23. All right, so there comes a point where, yeah, let's not start over. So we're going into the sketch. We have an oblong or a slot. And with the slot, we're going to pick. So I'm going to undo that real quick. So slot, our choices are center to center, center of the center line, midpoint of the center line to the end point, and then we have arcs and curved arcs start and end point. So if I pick and then drag, and then we drag out and place the brown, we have a radius of 0.38. A distance of the 1.66. All right, I still like the arc perimeter circumference that gives me the biggest target. And then for the 1.13, we can go center line. We can go to the pretty much any of the lines. We could go center to center on our slot arcs, and that would be about the same. And then 4.48. All right, we're going to cut that through. So extruded cut and blind. Nope, we want to go through all. So doing the pull down, let it figure out the thickness of the material. I'm going to hit Control S just to make a save. And then I want to do a what if scenario. So I'm going to introduce suppress. And when we right click, we have a third icon on the top row. And suppress says, I want to see what will happen if I do something different. All right. And suppress has a lot of functionality in what if scenarios. I'm not always sure what I want to do, how I want to do it. So in this case, I want to try the whole wizard slot. The drill sizes, we were at, well, we're going to call it 0.75. Let's see, while I'm here, 1.13 on the slot length. And we're going to go to 0.75. It is a through all, no countersinks, and position-wise, and we'll place it. All right, so just looking at this, it's longer. The slot length is on the geometry. So I'm going to have to make a little bit of a modification, and then this is still going to be able to move. And I'm going to forego, just on the interest of time, I'm going to forego positioning this so that we can finish seeing it. But notice that I went to the center line length, and if I pick that, because it is the line, I don't have a min-max condition. And let's see, am I confusing myself? The 1.13? No, actually it looks better going that way. Maybe it didn't adjust. All right, well, if I wanted this to be the min-max on the position, I would have to calculate that. So I got off on a tangent there. All right, so when I expand this out, sketch 18 is not going to be defined because I didn't put those dimensions on it. The 1.13 was okay. So I could stay with that, or I can suppress it and then unsuppress. If you end up with a conflict with both of them unsuppressed, well, one it grew a little bit, so probably not a good way to go. And then our last geometry to finish up is to do the contour, or the pocket, the square. And let's place that. All right, so I went into the rectangle and had not selected my sketch, so it was asking me as soon as I clicked the face, it says, yep, you're ready to go. And we're going to put in 150, 1.38, and 1.5. All right, and then the height, 1 inch and 1.5. If our intention is that this always be a square, the consideration becomes select, control select, equal. We're always positioning off of that corner, or we could look at positioning on the center and having it grow or shrink in the same proportion. All right, so just double clicking on the dimension. Assuming that these are through still, it could be a blind pocket, but we're going to make it through. All right, our last bit of geometry, we have a thickness, where the radius, no. Fillets and rounds, 25. All right, so technically a fillet is an external. And except for these inside, these would be the rounds, this would be the round. I'm just going to go ahead and hold down the control button and select, and then we'll go back and see what we get. So 0.25. All right. One of the considerations, oh, missed that one. So let's right click and edit the feature. Go back in and add the round. One of the considerations is that in our manufacturing process, round tools do not cut square holes. So at the very least, I would want maybe an 1/8 inch. For a 1/2 inch thick part, I would like to have a 1/4 inch diameter tool, which gives me a 1/8 inch or 125 radius. So I'm just going to drop those in as a what if. And tool lengths vary by manufacturer, but as a general rule, a 1/4 inch diameter end mill that I would be machining with would be 0.75, 3/4 of an inch long. So if I go into this fillet, I want it to be a little bit bigger so that it doesn't go real hard into that corner. I guess it will do that. Nice. How about we do a 0.13? That'll be a little closer. And when we look at some more manufacturing techniques, if this needed to be a square corner, then there are some techniques to overrun it. Kind of the same with this one, but we'll call it good there because I do want to go back and revisit our quarter inch, and I find that I need it to be a little more clearance, so I can switch to screw clearances. And a 257 F drill or a 266 G drill. Let's see, depending on what so we set screw clearances and we picked for a 1/4 inch screw through all. Normal, if I set it to close, I believe that's going to be the F257. Normal is going to be a 266. And the loose is going to be 270 something. So we'll leave it at normal and go ahead and accept. And we go from 250 up to 266. Right? I decide that, wow, I really looking at how this fits into the assembly later on, that I want this to be a tapped hole. It goes to 201. And it doesn't look like it updated the annotations, so let's go into the position. Yeah, so it should add cosmetic threads, but I'm not seeing that. We may also just have to rebuild it. All right, I'm going to have to look into that one. I know that there was a sequence to get them to add it. And then if we look at the other geometries, counter bore for a binding head, usually the binding head, and you would want to make sure that any of the other styles, the hexes, in the case of a hex, that your socket will fit. But the nice thing about the socketed cap screws with the hex being in the interior is we can get it to fill that geometry. And usually these are a little bit big. Looks like I missed that radius, so let's just go back to our fractional and 1/4 inch. Edit the fillet one more time. Get that one into the mix. Save it, and we'll call this one good.